Hello, my pre-calculus student. In this video, we are going to graph inverse sine function y equal a inverse sine of bx, where a and b are real numbers. There are 5 steps that we have to follow. So let's begin to go over these 5 steps. The first step, we have to graph the sine function first. So the function y equal a sine bx. Next, we have to select only a piece from the graph from step 1, the graph of the sine function from step 1. That's a one-to-one function. And the piece that we pick have to include the x-axis and the y-axis and the range from -a to a. And step 3, from there we are going to select at least 3 points, so I say few points, but you can select at least 3 points from the graph of sine function. And then step number 4. Step number 4, you are going to interchange the order of x and y in each point from step 3. And step 5, you are going to graph the inverse sine function by plus the point from step 4 and then connect the point with the curve. Okay, so now we are ready with the example. So let's start with the first example. So here we want to graph the function y equal -6 sine of 2x. So step 1, we are going to graph the sine function without the inverse notation, so we just graph y equals 6 sine of 2x. So from the notation, we'll be able to find out the periods. So periods is 2 pi divided by b, so b is 2, so 2 pi divided by 2 gives us pi. So, and then we also be able to find the amplitude from the given equation. So the amplitude is 6. So that gives us our y maximum and y minimum. So now we can scale 1, 2, 3, 4, 5, 6. So this will be our positive 6. 1, 2, 3, 4, 5, 6. So this will be -6. And the period is pi. So we are going to divide the periods into 4 equal intervals. Now you're welcome to spread them out so that you can see more. So in this case, I'm going to have to spread it out so that you can see. So 1, 2, so let me see, 1, 2, 3, 4. So much pi right here. Okay. So we divide the periods into 4 equal parts. And then so each one of the tick mark the first middle number will be pi over 4, and the next one will be 2 pi over 4, and then 3 pi over 4. So each time you increase by pi over 4. And then if you remember the pattern of the sine function will be 0. So it starts 0. If not, then we go ahead and make a table quick. So the table for the sine function, so this is x from 0 to pi, so pi over 4, 2 pi over 4, and 3 pi over 4. So our y value, so the pattern will go from 0, and then the maximum, so there's no reflection, so be 6, 0, -6, and 0. So 0, positive 6, 0, -6, 0. So this will be one period of the graph, and then you will connect these 5 points. So that will give you the first period of the graph of sine function. and then you just repeat the same pattern of the y value on the left hand side to graph the second period. So 1, 2, 3, 4. So this will be negative pi. So again, y equals 0, y equals 6. So 1, 2, 3, 4, 5, 6. Y equals 0, y equals negative 6. So 1, 2, 3, 4, 5, 6, and y equals 0. And connect the 5 point again. Okay, so that's the step 1. So we're done. We graph the sine function y equals 6 sine of 2x. So step 2, we are going to select a piece that is 1 to 1. One to 1 piece. Or we restrict the sine function. So in this case, you can see right here, the piece that we select must have the range from negative 6 to 6 and have to be closer to both x-axis and y-axis. So this will be the piece that we are going to select right here. And step 3, we are going to select the 3 points from the piece. So step 3, pick 3 points from step 3. So the 3 points that we are going to select, the first point will be negative pi over 4. So negative pi over 4, comma negative 6. The second point will be 0, 0. And the third point will be pi over 4, comma positive 6. Step 4, we interchange the x and y value. The x and y value of each point. So what it says is that the point. So let's start with the first point. The first point from step 3. Let me make a note. From step 3. So the first point be negative pi over 4, comma negative 6 become negative 6, comma negative pi over 4. The second point is still 0, 0. And the third point will be 6, comma pi over 4. So now we are ready to graph the point from step 3, from step 4 to the graph of inverse of sine. So the first thing we know that the domain will be from negative 6 to 6 will be 1, 2, 3, 4, 5, 6. So this is negative 6. And the range is positive 6. So, I'm sorry, the domain from negative 6 to 6. So 1, 2, 3, 4, 5, 6. And the range will be from negative pi over 4 to positive pi over 4. So we need to do this. So we make sure that you can see right here that your x is your y. So the x of the inverse is the y. So the domain of the inverse is the range of the given function, and the range of the inverse is the domain of the given function. So just interchange. So you see right here, the domain for this p will be go from negative pi over 4 to positive pi over 4. So it becomes the range. Negative pi over 4 to positive pi over 4. Okay, so now we plot the point. So the first point be negative 6, negative pi over 4. the second point be 0, 0. The third point be 6, comma, positive pi over 4. So now you have 3 points, and you connect your 3 points with the curve. So this is how the curve looks like. So first it can increase and then decrease. That's it. So these are the 5 steps. So the step 5 will be the graph. This is step 5. So let's write out the summary. In this video we learned this, how to graph inverse sine function of the form y equal a inverse sine of bx. Thanks for watching this video. I will see you in class. Goodbye.